let's see. Testing. Nope, that's the wrong mic. Let's see. Are we getting anything now? Yes, okay. In this video, we're going to build the first part of a Tic Tac Toe game using React. By the end, we'll have a working 3x3 board, reusable square components, and state that lets us alternate between X and O. Here I'm creating a new project called React Tic Tac Toe, selecting React and then installing the project dependencies. Once everything is installed, we can start the development server and open the project in the browser. Vite gives us some starter files and example content that we don't need, so I'm going to clean that up before we start building the game. For this project, most of our work will happen inside app.jsx, square.jss, and our CSS files. The first thing I want to create is a reusable component for each individual square on the board. Instead of manually writing 9 square buttons, we can create one square component and reuse it 9 times. Our square component accepts 2 props. The first is value. That determines whether the square is displaying an X, an O, or nothing at all. The second prop is onSquareClick. That gives the parent component a way to tell this square what should happen when the button is clicked. Inside the component, we return a button with the class named Square. The button's onClick event calls the function we received through onSquareClick, and the value is rendered inside the button. We then export the component so we can use it inside the app file. Now we can move into app.jsx. The first thing we need is React's useState hook. Our board has 9 positions, so we create an array containing 9 values. Squares contains the current state of the board, and setSquares gives us a way to update it. As the game progresses, those null values will be replaced with X's and O's. We also need to know whose turn it currently is. For that, I'm creating another state variable called xIsNext. Next, we need a function that runs whenever a player clicks one of the squares. I'm calling this function handleSquareClick, and it receives the index of the square that was clicked. The first thing we do is create a copy of the squares array. Instead of directly changing our existing React state, we create a new array using the spread operator. That gives us next squares. We can now update the position that was clicked. This is using a ternary operator. You can read it as if X is next, use X, otherwise use O. Once the new value has been added to the array, we call setSquares to update our React state. Then we switch xIsNext to the opposite value. So if X just moved, the next player will be O. Now that we're tracking whose turn it is, we can display that information above the board. Here I'm using another ternary expression. If xIsNext is true, we display X, otherwise we display O. Because this is React state, the text automatically updates every time a move is made. Now we need to actually render the board. Instead of manually creating 9 square components, we can map over the squares array. For each square, we pass its current value into the value prop. We also pass a function into onSquareClick. That function calls handleSquareClick and gives it the index of the square that was clicked. That index is what allows the handler to know exactly what position in our array needs to be updated. We also give each square a key. React uses keys to keep track of items when rendering lists as components of components. At this point, the basic game board is working. If I click one square, we get X. The current player changes to O. Then the next square gets O, and the turns continue alternating. So in this first part, we created a reusable square component. We used props to pass values and click handlers into those squares. We used useState to store the board and track whose turn it is. We used map to turn our state array into 9 React components. And we used event handlers to update the board when a player clicks. There's still one major problem with the game. Right now, I can click a square that already contains an X or an O and overwrite it. The game also has no idea when somebody has actually won. We're going to fix both of those problems in part 2. We'll prevent invalid moves, create the winning combinations, and add logic that detects when either X or O wins the game. That's it for part 1. If you want to continue building the game, I'll see you in part 2.